Hello, this is Mr. Bus. In this optional video, I'm going to walk through how to do these quiz questions on chi-square. I put two of them together. One of them is just about rolling dice, and another one is about a pea plant cross. And I got a number of messages, and that's awesome. I really, look forward to hearing back from folks and seeing how things are going. That this was a bit confusing, and I get it. It's tough distance learning. This is something that would probably have been better to go through in class together. But hopefully this video is helpful to walk you through these quiz questions. If you feel like you were guessing or not able to get 5 out of 5 on these and weren't sure how to get the right answers. So for this question, we're going to pretend we rolled the dice 120 times. I chose that number because, with 6 sides of a dice, 120 rolls is divisible by 6. And so that would be, an expected 20 rolls, statistically speaking, of each number. You'd expect to get 20 number 1s, 20 number 2s, 20 number 3s, 24s, 25s, and 26s. So again, I think that's the hardest thing for a lot of folks, is figuring out what the expected value is, because these are the observed values, right? These are the observed for each. So they're given to you. So the expected is kind of tricky. So, and again, because we had, to figure out the expected, we need to know how many total were there. Okay, and if there's 120 total, and there's 6 sides, right? 120 divided by 6 equals 20 per side. So we're going to expect 20 of each. Now, of course, we didn't get that. We got 15 ones. And so that's where chi-square equation comes in. So the chi-square, which is this chi-square, is going to equal the sum of the observed minus expected squared divided by expected. Well, observed is given to us. We now know our expected value for each of the 1 through 6 numbers is 20, because again, the total was 120, divided by 6 is 20. Now we can do this, and we're going to do this 6 times, because there's 6 sides of the dice. So we have to run this observed minus expected squared divided by expected. We actually have to set that up for each particular number. So I'm just going to go ahead and do that. Okay, so for number 1, we got 15, expected 20. The difference is 5. 5 squared over 20 equals 25 over 20. 25 divided by 20 equals 1.25. For number 2, we got 20, expected 20, 0. For number 3, we had 28 threes. So the difference between 28 and 20 is 8. 8 squared over 20. $64 divided by 20 is 3.2. For rolling 4, we had 17 of those. Difference between 17 and 20 is 3. So 3 squared over 20. 0.45. And number 5, for rolling a 5, we had 19 fives. Difference between 19 and 20 is 1. Squared is 1. Over 20 is 1 over 20. 0.05. And for 6s, we had 21 6s. Difference between 21 and 20 is 1. 1 squared is 1. Again, divided by 20 is 0.05. So if I add up these numbers here, and that's the summation thing, you add them up. So go ahead and do that. 1.25 plus 3.2 plus 0.45 plus 0.05 plus 0.05 equals 5. In my, I think in the Schoology question it said round to the nearest tenth of a decimal, so that'd be 5.0, but I made it so that correct answer could also be written as just 5. So 5 or 5.0 for that one. Okay, so that's the chi-squared value. And just solving this and talking it out, I think you should be able to answer all the other questions, like, what are the expected numbers of things. Actually, I guess I should go through quickly how to reference the table then, I suppose. So our calculated chi-square value is 5. And let's take a look at the chi-square table. We have to identify which row and column we're on. Now in the Schoology quiz, it said using a confidence value of 95% confidence. Okay, that would be the 0.05 column. So we're going to use that column. And then we use that row. And then the column that we use, we have to figure out our degrees of freedom. Degrees of freedom are equal to the number of distinct possible outcomes minus 1. Well, you can either roll a 1, a 2, 3, 4, a 5, or a 6. So 6 minus 1 equals 5. There's 5 degrees of freedom for this problem. Okay, so we're going to use 11.07 as our reference value. Excuse me. Our chi-square value is less. 5.0 is less. So we have less deviation than needed. And so what that means is that we're going to say that because we have less than 11.07, that the dice are just normal. We're going to go with our null hypothesis that the dice are not loaded dice, they're just regular dice. And the reason that we don't get 20 every time is just due to random probability, just random chance and stuff like that. So even though we've got 28 threes, that's not far enough away from what we'd expect to a 95% confidence that these dice have been tampered with.